person struggles to read by holding a book at arm's length, a distance 45 centimeters away. What power of reading glasses should be prescribed for her, assuming that they will be placed 2 centimeters from the eye and she wants to read at the normal near point of 25 centimeters? This problem will be solved by remembering 3 simple rules. First, people who wear glasses do not see objects, they see images. Second, object and image distances are measured from the lens, whereas near point and far point are measured from the eye. And finally, ideal vision is taken to be a far point of infinity and a near point of 25 centimeters. In the problem at hand, a person's vision has deteriorated because their near point is much further than 25 centimeters away. It's 45 centimeters. And so we wish to prescribe corrective lenses to allow this person to read comfortably. As always in prescription problems, it's a good idea to draw a detailed diagram so that we don't confuse any of the distances involved. We've seen that in the absence of corrective glasses, this particular person has a near point of 45 centimeters, which is what creates the difficulty in reading, and they would like to have a correction that would allow them to be able to read a book if the book were placed 25 centimeters from the eye. To make this correction, we're going to place glasses 2 centimeters in front of the eye, and recognizing that our equations will always involve distances as compared to the lens, we'll complete the labeling of this figure to note that we desire to be able to place the book 23 centimeters from the lens, whereas this person's near point, the closest at which they can focus, is actually 43 centimeters from the lens. Finally, to complete the figure, we always wish to label both sides of the lens, and we recognize that the light will be incoming from the book on the left of the lens and will go out of the lens to the right in order to enter the eye. Now we're able to calculate what kind of lens will be necessary in order to correct this person's vision. The book itself is to be placed a distance 23 centimeters away from the lens, and the book, being an object, is on the incoming side of the lens, and so that's a positive. The action of the lens will be to place the image at a location where the person can actually focus on it, and this person's near point is 43 centimeters away from the lens. Now we recognize that image locations are positive when the image is on the outgoing side, and this image is not on the outgoing side of the lens. Therefore, this image distance must be negative. Our goal will be to calculate the appropriate prescription for this person by specifying the focal length of the lens. Using the usual equation that applies to lenses or mirrors, and plugging in the values that we have, we determine a focal length of 49.45 centimeters. Although we have determined exactly the appropriate lens to apply to this problem, we recognize that the way the question was worded did not ask for the focal length of the lens. Instead, it asked what power of lens is appropriate. And we remember that the power of a lens, measured in the units known as diopters, is calculated by taking 1 over the focal length, where we ensure that the focal length is in the units of meters. Our focal length is just shy of half a meter, so it's no surprise when we plug in the numbers that we get just over 2.02 diopters. And that completes the prescription for this person's reading glasses.